All right, we're going to build on the stuff we talked about for trig last day. And first we're going to talk about some patterns and visualizing. Then we're going to get into actual calculations of angles. So the first thing I have to ask is sine 20 the same as cos 70? Now you could use your calculator and figure it out, but there's a way we can visualize and understand what's happening. So let's start by drawing a triangle. Okay, that's our right angle triangle. This is 20. This is opposite, adjacent, hypotenuse. If I set this up, my sine 20 would be equal to the opposite over the hypotenuse. Okay? So it would be this side over this side. Now, if we're doing cosine of 70, it's going to be a different triangle. But just pause for a sec. The total of all the angles in a triangle, any triangle, is 180. We know this is 90. We know that's 20, which means that has to be 70 in order to add up to 180. So if that was 70, it actually is the same triangle, it's just a different side, okay, or a different angle. Let's relabel the triangle. If we're looking at this 70, this is the adjacent, this is the opposite, and this is still the hypotenuse. That didn't change. So for cosine, it's adjacent over hypotenuse. And if we look, hypotenuse is still the same, it didn't change, okay? But then adjacent is actually this side, the yellow one right next to it. So if we think about it, these two are actually equal to each other. And so the pattern you would notice, no matter what triangle you made, if this number next to sine plus this number next to cos add up to 90, which means they're the same triangle, they're the same. So sine of 10 is the same as cos of 80, okay? Because these two add up to 90. That's just a pattern that always works because basically they're sharing the same sides in their ratios. The next one, trying to visualize triangles. This is going to be a really important skill, especially as you get into grade 11 and trying to understand the patterns that's happening. But so to visualize, I like to draw my triangles this way always, whatever angle, so let's say 20 degrees. This is always the right angle, okay? This is the opposite, the adjacent, the hypotenuse. When we're comparing triangles like sine 20 and sine 40, you want to make the hypotenuse stay the same, but the opposite and the adjacent are actually going to change. So I'm going to show you using a diagram, this like cool online representation. So you can see right here in this circle, this is say our sine 20. If we increase the angle, okay, so now this is a bigger angle that we're measuring, you'll notice that the opposite, the green side, is actually getting bigger, 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 and the adjacent is getting smaller, 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 smaller. Okay? We're not going to deal with triangles in these quadrants yet, in these three bottom ones. We're just going to focus right here. This would be more in grade 11 stuff. Okay? But so as you can see, opposite gets bigger, hypotenuse stays the same. So with that in mind, we want to think, if we have sine 20, which we know is going to be opposite over hypotenuse, and then we have sine 40, which is also opposite over hypotenuse. But like we said, it would be like, draw the circle to make it a little bit easier. Okay? Sine 40 would be like that. We can see the opposite side is clearly bigger than it used to be, which means if we compared these numbers, opposite to the new opposite, oops, did that backwards, old opposite, new opposite, okay? The new one, where it has the 40 degrees, is a bigger number. So if we have a bigger number divided by the same number, let's say this was like 2 over 4, and this was like 3 over 4, clearly this is a bigger number. So you can see, if you go from sine 20 to sine 40, the bigger angle is going to have a bigger sine ratio. However, if we did cosine, the same thing, versus cosine of 40, okay, as the angle increased, like we said, as it got more and more this direction, the adjacent actually got smaller. So in this case, the ratio of cos 20 would be bigger than cos 40. You do not have to memorize, which one's bigger, which way does it work. You do have to be able to visualize the triangle and try and figure out what makes sense, what's happening here. There's a couple special cases here when we have sine 90 cos 90 and sine 0 cos 0. This is really weird to try and understand. So this is our normal triangle, in the corner. This is our normal triangle, okay? And this is the angle we're dealing with. If we pump that angle up to 90 degrees, okay? So if we rotated it, it would be like this. And this opposite, which used to be over here, would keep moving inward until it was all the way right on top of it, okay? when we look at this, this is actually a 90-degree angle. It's really weird to conceptualize that as a triangle, but when we try and think of it using our ratios, opposite over hypotenuse, the opposite was this blue line, which is now here. The hypotenuse was this red line, which is now here. These two numbers, these two lines, are the exact same length. So we have the same length, so 1 over 1, that's just 1. So if we have sine of 90, the answer is 1, okay? Whereas if we do our cosine, let's try and figure that one out. That one's going to be adjacent over hypotenuse. So when we do adjacent over hypotenuse, this was our adjacent here, but then now our adjacent is 0. It's gone, okay? It's been smushed into oblivion. So that is going to be 0 over 1, whatever hypotenuse was, which is 0. That's why sine 90 is 1, cos 90 is 0. So now think for a sec, logically extending this idea, what would sine 0 be and what would cos 0 be? So our triangle instead would look like this. If our hypotenuse is the green one, okay, it would keep moving this way until it was smushed down into the ground like that, right on top of the adjacent. So here we can see the opposite, which used to be here, is now gone. It's squished into nothing. So our sine is going to be 0 over 1, okay, because our opposite is gone. But our cosine would be 1 over 1. Let's do a different color. 1 over 1, because our adjacent is the same length as hypotenuse, which is 1. Again, you don't have to memorize these numbers if you don't want to, but you need to be able to figure out how you can visualize these weird triangles. Yes, this is, like, in theory, a triangle to represent the pattern of what's happening. The last thing, and probably the most practical, is how to actually do these on a calculator. You will get some basic questions which will say, oh, what's sine 30 equal to exactly? Like as a decimal. On your calculator, all you have to do is press the sine button, and then press the 30 button, and then press equals, or type 30 and press equals. Some calculators, you have to press 30 first, and then you press sine, and when you press sine, it'll give you a number. Based on what we know sine is always going to be 0 point something, and cos is going to be 0 point something. Tan is weird and has lots of stuff. It can be like anything, okay? So when I put this in my calculator, I'm going to do sine 30, and it gave me 0.5. When I do cos 25, it gave me 0.9063. I'm just going to round that to 0.9, okay? And when I do tan 12, I got 0.21. These are very easy. You just need to know the basics of how to do it. Most questions, you're not going to actually do that, okay? Most questions, when we're dealing with triangles, it's more complicated. This is a much more practical skill. Okay? So we have a triangle and we figured out, all right, the ratio of opposite over hypotenuse is 0.1, but I need to know what that angle is. So the problem is I want it to say x. I want it to say x equals a number. But right now it's got stupid sign with it. So you need to think back to last year when we did algebra. When we had questions like this, 3x equals 9. Okay? We wanted x by itself. So we had to get rid of the 3. And to get rid of the 3, we always did the opposite. So the opposite here, this is multiplication, so the opposite was division. And we do it to both sides. So we're going to do the same thing here. We need to get rid of sine. So we need to do the opposite of sine. The opposite of sine is this thing called inverse sine, which looks like this. The little -1. On your calculators, where you have the sine button, okay, right above it in orange, it probably says this, -1. So in order to make your calculator do that, you need to press a button called second, or second function or whatever. It's usually at the top left of your calculator. When you press that, when you press the sine button, instead of doing sine, it'll do inverse sine. And if you have a nice calculator, it'll actually say inverse sine. So when I do this, if I do inverse sine to both sides, these will cancel out, and I'll be left just with x. And then my calculator, I'm going to do inverse sine of 0.1. You don't have to put the brackets. I like to put it just to make it clear. So when I do that on my calculator, I get 5.739. Now, just think for a sec. This was an angle, so I need to put my units. That's going to be degrees. That's a common error that people forget when they figure out what the angle is, but they don't actually write the units. Cosine and tangent work the exact same way, except instead of pressing inverse sine, you do inverse cos or inverse tan, okay? So when I do these on my calculator, and the reason I'm showing you these is you should try it on your calculator. If you don't get the right answer, you made a mistake. The other thing is most calculators have a button where you can change between degrees, radians, and gradients. Okay, you want to be in degree mode for this year. In future years, you'll use the other stuff, but for right now, we're measuring angles using degrees. So for this one, I'm going to do inverse cos of 0.2. That gave me 78.46 degrees. And then the last one for tan, I'm going to do inverse tan of 0.5, and it gave me 26.56557 degrees. These are going to be super useful when we talk about how to actually solve triangles in the next lesson. Make sure that you are able to put these in your calculator and solve them. And that's basically it.